Hello friends, welcome you all. So this is today's topic is pumping lemma for regular language. This is basically a test to check whether the given language is regular or not. So before starting the discussion, I would like to tell you an important thing about this test. So suppose for any test if you are performing, so there are two possible results. One is positive result and other is negative result. One is positive result and other is negative result. In case of negative result, if suppose if we are applying this test on some language L, which we are considering as a regular language already. So if the result of this test is negative, then we can say the language is not regular. Language is not regular. So here, if in case of negative result, language is given language is non-regular language, non-regular language, and and you can see here if the negative result we are getting, then we can surely say it is sure, or you can say decidable that that particular language is non-regular language. Now, if the result of test is positive, there is again not sure, we are not sure, it is basically undecidable whether the given language is regular or not, whether the given language is regular or not. So, if some language is giving us positive result in this test, that means again it may or may not be regular. It may or may not be regular. But if the result of this test is negative, then we can surely say, yes, that language is non-regular language. So this test is basically negative kind of test. So now I will discuss how to apply this test on some particular language. So I will take one language as example. So friends, this is the statement of pumping lemma. If any regular language L is given to us, then there exists one positive number N for any string W which is belonging to the language L, and the length of W is greater than or equal to N. Then we can divide W in three different strings X, Y, and Z such that for any positive number I, X, Y to the power I, and Z still belong to the language L. It still belongs to the language L. So now these these two conditions must be satisfied when we are dividing any string W in X, Y, and Z. What these conditions are that the length of Y must be greater than zero, must be greater than zero. That means it cannot be empty or epsilon. Y cannot be epsilon. At least one symbol must be there in Y, and the combined length of x and z z must be less than or equal to n, which is our positive number. So these two conditions if we are satisfying, then we can check this condition also, and if this condition is also being satisfied, then we consider the positive result for this language. And if this condition is not satisfied for all values of I, then we can say this is giving negative result for that particular language. So if in case of negative result, we can surely say this is non-regular language. So I will take one language as an example here. So I'm taking a to the power n, b to the power 2n, a to the power n, and b to the power 2n. Now, this is the language where n is greater than or equal to 0. Where n is greater than or equal to 0. So now you can say, see my friend, for n, minimum value of n is 0. So that string, in that case, 0 occurrences of a and zero occurrences of B would be there. So this would be epsilon. So epsilon is valid string for this language. Now for n equal to 1 occurrence of A would be there and 2 occurrences of B would be there. So as many A number of A's we have, that the number of B's would be exactly double of that. So this is the language. Now we can consider the value of n, any positive number here. So I'm considering the value of n here as 8, as 8. So now as 8 we are taking the value of capital N here. So now we can take any string W from this language. So we are considering this language as regular language already. So we are taking one language string here. A gives B, 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 B. As the number of A are 3 here and the number of B are 6 here, so this is a valid string from this set. This is valid string from this set. So this you can consider as W. This you can consider as W. Now this condition is already getting satisfied. Now we check this condition. The value of n is 8. The value of n, capital N is 8. So now we will check the length of W. So the length of W here is 6 plus 3. So the length of W is 9. Length of W is 9. And this condition is also satisfied. This condition is also getting satisfied. Now we can, if these two conditions are satisfied, then we can divide W in X, Y and Z such that they will satisfy these two conditions also. Now, so we will divide this string into X, Y and Z. So let's take X as, for first four alphabets of this number, or first four symbol of this number are there in X. Now next two symbols are there in Y and last three symbols are there in Z. So these are three strings X, Y and Z. Now let us check whether they are satisfying these two conditions or not. So the length of W here, length of Y here is 2, which is greater than 0. So that means this condition is getting satisfied. Now the combined length of X and Z, the length of X here is 4 and the length of Z here is 3. So combined length of X and Z would be 7, which is less than or equal to 8. So this condition is also getting satisfied. Now we can take any positive value of I. If for all values of I this condition is also getting satisfied, then we can say the result is positive for this language. Now uh, this I can have any value from 0 to any positive number. So you can start from any value of I from 0 itself. Now I will consider first value of I here as 1. So for I equal to 1, for I equal to 1. So I can, for I equal to 1, that string would be the same as W. So A, B, 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 B. And this would be belonging to the language. So yes, it is belonging to the language. Now for I equal to 2, the string would be A, B. This is X. Then two occurrences of Y. So that means B, B, one occurrence, and then second occurrence B, B, and then Z. So B, B, B. Now you can check. The number of A's are 3 and the number of B's are 6 plus 3, 3 plus 3 plus 2, 8. So this is not belonging to that language. This is not belonging to that language. So that means this condition is not satisfied for value of I is equal to 2. And if we take I equal to 3, then again this would not be satisfied. For any value of I greater than 1, it will not be satisfied. So this condition is not getting satisfied for all values of I, and that means this language is giving negative result for this test. So it means this language is non-regular language. This language is non-regular language. This n is known as pumping length of pumping length of string w, and this I can have any value starting from 0 to any positive number. I hope it is very much clear to you, and if you have any doubt, you can always write to me in comments. I will definitely reply your comments. Thank you so much.